A battery electric vehicle (BEV), pure electric vehicle or all-electric vehicle is a type of electric vehicle (EV) that uses chemical energy stored in rechargeable battery packs. BEVs use electric motors and motor controllers instead of internal combustion engines for propulsion. They derive all power from battery packs and thus have no internal combustion engine, fuel cell, or fuel tank. BEVs include, but are not limited to, motorcycles, bicycles, scooters, skateboards, rail cars, watercraft, forklifts, buses, trucks, and cars. In 2016 there were 210 million electric bikes worldwide used daily. Cumulative global sales of highway-capable light-duty pure electric car vehicles passed the 1 million unit milestone in September 2016. As of April 2018, the world's top-selling highway-legal all-electric car in history is the Nissan Leaf with global sales of over 300,000 units, followed by the Tesla Model S with more than 200,000 units delivered worldwide. Terminology. Vehicles using both electric motors and internal combustion engines are examples of hybrid electric vehicles, and are not considered pure or all-electric vehicles because they cannot be externally charged, operate in charge-sustaining mode, and instead they are continually recharged with power from the internal combustion engine and regenerative braking. Hybrid vehicles with batteries that can be charged externally to displace some or all of their internal combustion engine power and gasoline fuel are called plug-in hybrid electric vehicles (PHEV), and run as BEVs during their charge-depleting mode. PHEVs with a series powertrain are also called range-extended electric vehicles (REEVs), such as the Chevrolet Volt and Fisker Karma. Plug-in electric vehicles (PEVs) are a subcategory of electric vehicles that includes battery electric vehicles (BEVs), plug-in hybrid vehicles (PHEVs), and electric vehicle conversions of hybrid electric vehicles and conventional internal combustion engine vehicles. In China, plug-in electric vehicles, together with hybrid electric vehicles, are called new energy vehicles (NEVs). However, in the United States, neighborhood electric vehicles (NEVs) are battery electric vehicles that are legally limited to roads with posted speed limits no higher than 45 miles per hour (72 kilometers per hour), are usually built to have a top speed of 30 miles per hour (48 kilometers per hour), and have a maximum loaded weight of 3,000 pounds. Vehicles by type. The concept of battery electric vehicles is to use charged batteries on board vehicles for propulsion. Battery electric cars are becoming more and more attractive with the advancement of new battery technology lithium-ion that have higher power and energy density, i.e., greater possible acceleration and more range with fewer batteries, and higher oil prices. BEVs include automobiles, light trucks, and neighborhood electric vehicles. Rail. Battery electric railcars, locomotives, electric rail trolley. Electric bus. Chattanooga, Tennessee operates 9 zero-fare electric buses, which have been in operation since 1992 and have carried 11.3 million passengers and covered a distance of 3,100,000 kilometers (1,900,000 miles). They were made locally by Advanced Vehicle Systems. Two of these buses were used for the 1996 Summer Olympics in Atlanta. Beginning in the summer of 2000, Hong Kong Airport began operating a 16-passenger Mitsubishi Rosa electric shuttle bus, and in the fall of 2000, New York City began testing a 66-passenger battery-powered school bus, an all-electric version of the Bluebird TC 2000. A similar bus was operated in Napa Valley, California for 14 months ending in April 2004. The 2008 Beijing Olympics used a fleet of 50 electric buses, which have a range of 130 kilometers (81 miles) with the air conditioning on. They use lithium-ion batteries, and consume about 1 kWh per mile, 0.62 kWh per kilometer, 2.2 megajoules per kilometer. The buses were designed by the Beijing Institute of Technology and built by the Jinhua Coach. The batteries are replaced with fully charged ones at the recharging station to allow 24-hour operation of the buses. In France, the electric bus phenomenon is in development, but some buses are already operating in numerous cities. PVI, a medium-sized company located in the Paris region, is one of the leaders of the market with its brand Gepabus, offering Oreos 2X and Oreos 4X. In the United States, the first battery-electric, fast-charge bus has been in operation in Pomona, California since September 2010 at Foothill Transit. The Proterra Ecoride BE35 uses lithium titanate batteries and is able to fast charge in less than 10 minutes. In 2012, heavy duty trucks and buses contributed 7% of global warming emissions in California. In 2014, the first production model all-electric school bus was delivered to the Kings Canyon Unified School District in California's San Joaquin Valley. The bus was one of 4 the district ordered. This battery-electric school bus, which has 4 sodium-nickel batteries, is the first modern electric school bus approved for student transportation by any state. In 2016, including the light heavy-duty vehicles, there were roughly 1.5 million heavy-duty vehicles in California. The same technology is used to power the Mountain View community shuttles. This technology was supported by the California Energy Commission, and the shuttle program is being supported by Google. Thunder Sky. Thunder Sky, based in Hong Kong, builds lithium-ion batteries used in submarines and has 3 models of electric buses, the 1021st passenger EV6700 with a range of 280 km (170 miles) under 20 minutes quick charge, the EV2009 city buses, and the 43-passenger EV2008 highway bus, which has a range of 300 km (190 miles) under quick charge 20 minutes to 80% and 350 km 220 miles under full charge 25 minutes. The buses will also be built in the United States and Finland. Topic: Free Tindo. Tindo is an all-electric bus from Adelaide, Australia. The Tindo, Aboriginal word for sun, is made by Designline International in New Zealand and gets its electricity from a solar PV system on Adelaide's Central Bus Station. Rides are zero fare as part of Adelaide's public transport system. First fast charge, battery electric transit bus. Proterra's Ecoride BE35 transit bus, called the Ecoliner by Foothill Transit in West Covina, California, is a heavy-duty, fast-charge, battery electric bus. Proterra's ProDrive drive system uses a UQM motor and regenerative braking that captures 90% of the available energy and returns it to the teravolt energy storage system, which in turn increases the total distance the bus can drive by 31 to 35%. It can travel 30 to 40 miles on a single charge, is up to 600% more fuel efficient than a typical diesel or CNG bus, and produces 44% less carbon than CNG. Electric trucks. For most of the 20th century, the majority of the world's battery electric road vehicles were British milk floats. The 21st century saw the massive development of BYD electric trucks. Electric vans. In March 2012, Smith Electric Vehicles announced the release of the Newton Step Van, an all-electric, zero-emission vehicle built on the versatile Newton platform that features a walk-in body produced by Indiana-based Utilimaster. BYD supplies DHL with electric distribution fleet of commercial BYD T3. Electric cars. A battery-powered electric car is an automobile which is propelled by electric motors. Although electric cars often give good acceleration and have generally acceptable top speed, the lower specific energy of production batteries available in 2015 compared with carbon-based fuels means that electric cars need batteries that are fairly large fraction of the vehicle mass but still often give relatively low range between charges. Recharging can also take significant lengths of time. For journeys within a single battery charge, rather than long journeys, electric cars are practical forms of transportation and can be recharged overnight. Electric cars have the potential of significantly reducing city pollution by having zero tailpipe emissions. Vehicle greenhouse gas savings depend on how the electricity is generated. With the current U.S. energy mix, using an electric car would result in a 30% reduction in carbon dioxide emissions. Given the current energy mixes in other countries, it has been predicted that such emissions would decrease by 40% in the UK, 19% in China, and as little as 1% in Germany. Electric cars are expected to have a major impact in the auto industry given advantages in city pollution, less dependence on oil, and expected rise in gasoline prices. World governments are pledging billions to fund development of electric vehicles and their components. The U.S. has pledged $2.4 billion in federal grants for electric cars and batteries. China has announced it will provide $15 billion to initiate an electric car industry. In 2015, it was the first time BYD also ranked first in accumulated global sales throughout an entire year, with a total of over 43,073 NEVs sold, a greater than 220% surge compared to last year, exceeding all American, Japanese, and European leaders to date. Cumulative global sales of highway-capable battery electric cars and vans passed the 1 million unit milestone in September 2016. The Renault-Nissan alliance is the leading all-electric vehicle manufacturer. The alliance achieved the sales milestone of 350,000 all-electric vehicles delivered globally in August 2016. Ranking second is Tesla Motors with over 139,000 electric cars sold between 2008 and June 2016. As of December 2016, the world's top-selling highway-capable all-electric car in history is the Nissan Leaf, released in December 2010, with global sales of more than 250,000 units, followed by the Tesla Model S with more than 158,000 units delivered worldwide. Ranking next are the BMW i with about 65,500 units, and the Renault Zoe with 61,205 units, both through December 2016. Until June 2016, the Mitsubishi i-MiEV family ranked fifth with about 37,600 units delivered globally. The Renault Kangoo ZE utility van is the leader of the light-duty all-electric segment with global sales of 25,205 units through December 2016. Formula E is a fully electric international single-seater championship. The series was conceived in 2012, and the inaugural championship started in Beijing on 13 September 2014. The series is sanctioned by the FIA. Alejandro Agag is the current CEO of Formula E. The Formula E Championship is currently contested by 10 teams with 2 drivers each. After the withdrawal of Team Trulli, there are temporarily only 9 teams competing. Racing generally takes place on temporary city center street circuits which are approximately 2 to 3.4 kilometers (1.2 to 2.1 miles) long. Currently, only the Mexico City Ypres takes place on a road course, a modified version of the Autódromo Hermanos Rodríguez. Topic: Environmental benefits of the use of electric vehicles. Electric vehicles produce no GHG emissions at the tailpipe. So they are considered green because they have no emissions in the place where they are used. However, battery electric vehicles can be considered zero-emission engines only locally, because they generally produce GHG in the power plants where electricity is generated. The 2 factors driving these GHG emissions of battery electric vehicles are the carbon intensity of the electricity used to recharge the electric vehicle, commonly expressed in grams of CO2 per kilowatt-hour, the consumption of the specific vehicle in kilometers per kilowatt-hour. The carbon intensity of electricity can largely vary, depending on the electricity mix of the geographic region where electricity is consumed. A country with high shares of renewables in his electricity mix will have a low CI. In the European Union, in 2013, the carbon intensity had a strong geographic variability, but in almost all the member states electric vehicles were «greener» than conventional ones. On average, electric car saved 50% to 60% of CO2 emissions compared to diesel and gasoline-fueled engines. Moreover, the decarbonization process is constantly reducing the GHG emissions due to the use of electric vehicles. In the European Union, on average, between 2009 and 2013 there was a reduction of the electricity carbon intensity of 17%. In a life cycle assessment perspective, considering the GHG necessary to build the battery and its end of life, the GHG savings are 10 to 13% lower. Environmental disadvantages of the use of electric vehicles. Although electric cars do not produce any tailpipe emissions, carbon dioxide is still emitted when the electric vehicle is being manufactured. The lithium-ion batteries used in the vehicle take more materials and energy to produce because of the extraction process of the lithium and cobalt essential to the battery. This means the bigger the electric vehicle, the more carbon dioxide emitted. The mines that are used to produce the lithium and cobalt used in the battery are also creating problems for the environment, as fish are dying up to 150 miles downstream from mining operations due to chemical leaks, and the chemicals also leak into the water sources the people that live near the mines use, creating health problems for the animals and people that live nearby. Special purpose vehicles. Special purpose vehicles come in a wide range of types, ranging from relatively common ones such as golf carts, things like electric golf trolleys, milk floats, all-terrain vehicles, neighborhood electric vehicles, and a wide range of other devices. Certain manufacturers specialize in electric-powered in-plant work machines. Electric motorcycles, scooters and rickshaws. Three-wheeled vehicles include electric rickshaws, a powered variant of the cycle rickshaw. The large-scale adoption of electric two-wheelers can reduce traffic noise and road congestion but may necessitate adaptations of the existing urban infrastructure and safety regulations. From India, a new and renewable energy company is going to launch 2 models of electric scooters at the end of 2018, with lithium iron phosphate battery technology. Electric bicycles. China has experienced an explosive growth of sales of non-assisted e-bikes including scooter type, with annual sales jumping from 56,000 units in 1998 to over 21 million in 2008, and reaching an estimated 120 million e-bikes on the road in early 2010. China is the world's leading manufacturer of e-bikes, with 22.2 million units produced in 2009. Some of the biggest manufacturers of e-bikes in the world are BYD, Geely. Personal transporters. An increasing variety of personal transporters are being manufactured, including the one-wheeled self-balancing unicycles, self-balancing scooters, electric kick scooters, and electric skateboards. Electric boats. Several battery electric ships operate throughout the world, some for business. Electric ferries are being operated and constructed. Technology. Motor controllers. The motor controller receives a signal from potentiometers linked to the accelerator pedal, and it uses this signal to determine how much electric power is needed. This DC power is supplied by the battery pack, and the controller regulates the power to the motor, supplying either variable pulse width DC or variable frequency variable amplitude AC, depending on the motor type. The controller also handles regenerative braking, whereby electrical power is gathered as the vehicle slows down and this power recharges the battery. In addition to power and motor management, the controller performs various safety checks such as anomaly detection, functional safety tests and failure diagnostics. Battery pack. Most electric vehicles today use an electric battery, consisting of electrochemical cells with external connections in order to provide power to the vehicle. Battery technology for EVs has developed from early lead-acid batteries used in the late 19th century to the 2010s, to lithium-ion batteries which are found in most EVs today. The overall battery is referred to as a battery pack, which is a group of multiple battery modules and cells. The battery pack powering modern EVs can have as little as 96 battery cells to as many as 2,976 cells. Motors. Electric cars have traditionally used series wound DC motors, a form of brushed DC electric motor. Separately excited and permanent magnet are just two of the types of DC motors available. More recent electric vehicles have made use of a variety of AC motor types, as these are simpler to build and have no brushes that can wear out. These are usually induction motors or brushless AC electric motors which use permanent magnets. There are several variations of the permanent magnet motor which offer simpler drive schemes and/or lower cost, including the brushless DC electric motor. Once electric power is supplied to the motor from the controller, the magnetic field interaction inside the motor will turn the drive shaft and ultimately the vehicle's wheels. See also